In this today's mock test series, we are going to see most expected questions, your short questions for your JEE Main. Hope you are practicing well, do more and more problems, try to solve the question papers. Let's start with the first question. Acetanilide on treatment with bromine in acetic acid yields X. X on treatment with acidified water gives Y. They are asking they are not asking what is Y, they are asking what is the ratio of bromine and nitrogen in the compound Y. So you have to know what Y is, obviously, right? So what is acetanilide first of all? I know aniline, right? Aceto group, what is that? CH3CO. So one of those hydrogen is get replaced by COCH3, that is acetanilide. Correct? How we can prepare it? Using acetic anhydride, that you know. That with bromine in acetic acid. So what that will produce? First of all, bromine with acetic acid, it's an electrophilic substitution reaction. What kind of species this is? Electron withdrawing or electron donating? It is an electron donating group, right? NHCOR, it is an electron donating group which will have plus M effect. So, which will lead to the incoming electrophile to para position. So, NHCOCH3. That yields X on treatment with acidified water. It will undergo hydrolysis to form bromoaniline. Correct? But I have acetic acid. Right. So what is the ratio of bromine and nitrogen over here? Bromine is 1, nitrogen is also 1. The answer to this question is 1:1. Okay, very simple question, but it can be asked. The next one from DNF block. I told you electronic configuration in DNF block are important. Stick with NCERT. Correct. So number of elements with 10 electrons in the 4D subshell. So F block elements you see lanthanum, cerium, promerium, samarium, gadolinium, europium, yttrium, lutetium. Right? Which are all having 4F electrons. So which means that already filled 4D subshell. Correct? So which means these are all having 10 electrons in DD, 4D. Then what about scantium? Obviously not, that is 3D element. And what about yttrium? That is atomic number 39, which is not having complete 10 electrons, that is having 4D1 configuration. What about actinium? Of course it will have, that is actinium series. So must have filled 4D. Then silver and palladium. So silver and palladium, which is having the exceptional configurations. So silver, that after krypton, that will have 4D10, 5s1, and palladium also after krypton 4D10 configuration. So these two will have, zinc will not have, that we know. So only first these elements and actinium and silver palladium will have 4D10 electrons. Identify the correct statement. OCH3 and NHCOCH3 are activating group. This question is entirely about electron withdrawing group and electron donating group, how it goes, the electrophilic aromatic substitution. Okay. So first of all, OCH3 and NHCOCH3 are activating group. Always remember one thing, electron withdrawing group. Okay, that they are deactivating and directs to meta position. Electron donating group, that is activating, that directs the incoming electrophile to ortho or para position or both, depend on the reagent. Here we have halogens. Halogens are deactivating but directs the electrophile to ortho and para position. Okay. So the OCH3 and NHCOCH3 are activating group, electron donating group, that is right. CN and OH are meta directing group. These are different. CN is an electron withdrawing group and OH is an electron donating group. That is OH is ortho-para directing. So which is not a correct statement. CN and SO3H, they are meta directing. Yes, both are electron withdrawing group. So C statement is right. And what about the activating groups act as ortho and para directing groups? Yes, that is true. Halides are activating groups. That is the twist. We have halogens are deactivating but ortho para directing. So which is not a correct statement. So the answer to this question is A, C, D are right. Consider the following half cell reaction. Cr2O7 2 minus 6 electrons plus 14 hydrogen H plus gives 2 Cr3 plus 7 H2. The reaction was conducted with the ratio of this is equal to 10 to the power minus 6. The pH value at which the EMF of the half cell will become 0 is. We have to find out the pH value. So we can start by using the Nernst equation. E is equal to E naught minus 491 by N log Q. So what is the N value? How many electrons have been changed here? 6 electrons, right? Plus 6 state 2 plus 3 state, that also 2 chromium is involved. So 6 electrons over here. And what about the Q value? So Q is equal to Cr3 plus 2 by Cr2O7 2 minus, correct? And then we also have H plus. So let's substitute the values over here. They have given the condition that EMF of the half cell will become 0, right? So 0 is equal to, substitute the values over there, 0 is equal to 1.33 minus 0.059 by 6 log Q value. Okay, so this value I know that is given as 10 to the power minus 6. So 10 to the power minus 6 divided by H plus to the power 14. So by simplifying this, you will get H plus power will come before. So 135.25 is equal to log 10 to the power 6 minus 14 log H plus, correct? So this power also I am taking inside. So minus 6 minus 14 log H plus. So overall it will become log H plus is equal to minus 10.09. So what is the pH then? pH is equal to this value which is around 10, correct? So answer to this question is 10. If the freezing point of 0.01 molar aqueous solution of Gopal 3-chloride ammonia complex, which behaves as a strong electrolyte, the freezing point is given as 0.0558. The number of chlorides in the coordination sphere of the complex is. So whenever they are asking this type of question, what we have to concentrate on by the time you know, want-off factor, right? So delta TF is equal to I KF M. So what is the change? 0.0558 is equal to I don't know. KF value is given 0.86. M, that is 0.01 molar solution. Just to solve this, you will get an I value as 3. So which means I must have got 2 as an ionization sphere and 1 in the coordination sphere. So they are asking about coordination sphere, that is 1. If they are asking about outside the sphere, then that will be 2. Isothermic reaction, Kp and Kp dash are the equilibrium constants at temperature T1 and T2. Assuming that the heat of the reaction is constant at temperature range between T1 and T2, it is readily observed that. Okay, so we know that ln K2 by K1, that is equal to minus H0 by R 1 by T2 minus 1 by T1. So they mentioned that is an exothermic reaction. So where the delta H0 value is less than 0. Correct. So that will be negative value. Ln Kp and Kp dash. So Kp dash and Kp, that will also be less than 0. Kp dash is less than Kp. So for an exothermic reaction, as the temperature increases, what will happen? The K will decrease. So if T2 is greater than T1, then Kp will be greater than Kp dash. For solutions were prepared by mixing different volumes of NaOH and HCl of different concentration. These are the different volumes and concentration given. pH of 1, which of them will be equal to 1? So which of these are having the pH that's equal to 1? So let's try to solve one by one. 60 ml of m by 10 HCl, 40 ml of m by 10 NaOH. So both are having the same N factor. So 60 ml of 1 molar, 1 by 10, that will give you the millimoles as 6 millimole, correct? And for NaOH, 40 ml of 1 by 10 NaOH, that is equal to 4 millimoles. So how much the excess HCl will be? That will be 2 millimoles. So after neutralization, whatever the H plus ions are there, that will give you the H plus concentration, right? So H plus will be total of 100 ml solution and 2 millimole is excess. So 2 by 100 ml, that is equal to 0.02. 0.02, that is your H plus concentration. So if I am substituting in the pH value, I will get 1.69 as your pH. So similarly, you can calculate for B, C and D. Let me know what are the pH you get for B, C, D. This is how you have to solve the problem. And which will then approximately equal to 1? Let me know. The first ionization enthalpy of carbon, silicon, germanium and tin are in the order they have given. If the second ionization enthalpy of carbon is this much, and considering the trends in group 14, the second ionization enthalpy of tin will be. Okay, so we know that ionization enthalpy increases on moving left to right and decreases on moving from top to bottom. So these are carbon, silicon, germanium, tin, all are from carbon group, in carbon family. As you can see, the ionization energies are decreasing, and second ionization enthalpy of carbon, that is 2352. So this to this, there will be a, this is 1086, so that is 700. If I am calculating the ratio of first ionization energy and second ionization energy of carbon, then I will get, this is 2352 and this is around 2, right? So for tin also that will be around 2, 708 into 2, that is 1400. So answer to this question is 1412. The reaction 2A plus B gives product. The rate law R is given. If the volume of the reaction vessel is reduced to 1/3 of its original volume at constant temperature, the reaction will become. So the initial rate is given as R is equal to KAB to the power 2. If the volume of the reaction vessel is reduced to 1/3 of its initial volume, so nu A will become 3A and nu B, that will become 3B. Why is it so? Because the concentration becomes 3 times as original when the volume is reducing to 3 times. 2A is giving B. Now let's substitute the values. R2, that is equal to K 3A 3B over 2, that would be 9B B square and 3A, so 9 into 3 27, 27 K A B square, correct? So 27 times that will change from the initial rate law expression. The solubility product of AgCl is 1.6 into 10 to the power minus 10 at 25 degrees Celsius. Calculate the maximum amount of AgCl that can dissolve in 500 ml of 0.1 molar NaCl solution. So KSP, which is equal to for AgCl, Ag plus and the Cl minus, correct? KSP value is given as 1.6 into 10 to the power minus 10 equal to Ag plus and Cl minus. It's given as for NaCl 0.01. So 0.01, which will give you the Ag plus value as 1.6 into 10 to the power minus 8 molar. So moles of AgCl, that is equal to, I have 1.6 into 10 to the power minus 8 in 500 ml. So 0.5, that becomes 8 into 10 to the power minus 9 moles. Now the mass of AgCl, if I want to find, they have given Ag is 108, Cl is 35.5. So mass, that is equal to 8 into 10 to the power minus 9 into 143.5, that is 1.148 into 10 to the power minus 6. Multiply your answer by 10 to the power 6. So you will get 1 as your approximate answer. Choose the correct test with the respecting observation. Copper sulfate acidified with acetic acid plus potassium complex, potassium with iron complex, that will give you chocolate brown precipitate. So that is right, that will give you reddish brown of copper ferrocyanide precipitate. Then the next one, FeCl3 with again the same complex, that will give you Prussian blue precipitate, which is ferrocyanide. That is also right. And statement C, zinc chloride with this complex, cyano complex, neutralized with ammonium hydroxide, white or bluish white precipitate. So that is zinc ferrocyanide, that is in white precipitate. That is also right. And talking about D, MgCl2 with the complex gives blue precipitate. MgCl2 or Mg2 plus does not form a color precipitate with the ferrocyanide, so which makes this isn't wrong. And the statement E, barium chloride with the complex neutralized with NaOH gives white precipitate. So that is true. It happens at an alkaline medium to form a white precipitate of barium ferric complex. So A, B, C, E are right answers. Compound within molecular formula COCl3, 5NH3 and H2O shows the two isomers. Okay, isomer A reacts with excess of AgNO3 to precipitate 3 equivalents of AgCl. Okay, this type of question, if you see, then confirm your marks there. Okay, you should get 4 marks there. So 3 equivalents of AgCl, which means outside the coordination sphere, I'm having 3 Cls. So check for the option. I have option A and option C like that. Correct? Then, while isomer B precipitate 2 equivalents of AgCl, one immediately and second after standing or gentle heating. So anyhow, that is giving us 2 equivalents of AgCl. So comparing C and A, obviously the answer becomes A now. Right? So they have mentioned it one immediately and the second after some standing, because I have water also over there. So which one disturb the reaction? So anyway, the answer becomes A. The product of the following reaction is P. Number of hydroxyl groups present in the product P. That's your question. So here I have CHO group and then OH group. Right. So what can happen? But I have only one Grignard reagent, one equivalence of Grignard reagent, and aqueous ammonium chloride. First of all, which will get attacked first? Which can get attacked by the Grignard reagent, OH group or CHO group? Let's check for basically what is Grignard reagent. This will have a minus group and this will be plus. Carbon will get attacked by the electron rich group. Right. So if the carbon is having electron deficiency, or if the atom is having electron deficiency, then that can take up the Grignard reagent. Right. So in that case, already this aldehyde group is getting more electrons from OH, lone pairs of OH, right? So which will not taken up by the Grignard reagent. So it can take from this O, PH, and CHO will remain in the same position with NH4Cl, aqueous NH4Cl, which will lead to the formation of again OH CHO, right? So the number of hydroxyl group in the product, that is 1. The next question, the buffer solution is mixed by preparing 0.1 molar acetic acid, 0.1 molar sodium acetate in equal volumes. So equal volumes and 200 ml of this buffer. So which means this is 50 ml and this is 50 ml. Okay. To this buffer, 0.1 ml of 1 molar HCl is added. The pH of the buffer before and after addition of HCl will change by approximately. How much that will change? Okay. So first let's calculate the pH we have. That is pH is equal to pKa plus log of salt by acid concentration, right? So pH is equal to pKa value that is given as 4.74 log of acid concentration 0.1 molar of 50 ml, which is equal to, okay, already we have molar, that is 0.1, and here also 0.1, so which will be log 1, that is 0. So pH is equal to 4.74. Now the new pH we have to find. For that we have to know the concentrations. Now after adding 0.1 ml of 1 molar HCl, so initially how many millimoles that has? Initially acetic acid is 50 ml of 0.1 molar, that is 5 millimoles. Similarly for sodium acetate, that is 50 ml of 0.1, that is also 5 millimole. After adding HCl, how much HCl? 0.1 ml of 1 molar HCl, that is 0.1 millimole. So after adding HCl, what will happen to the concentration? So HCl will get dissociated as H plus and Cl minus. That can interact with this guy, sodium acetate, to form acetic acid, right? So the new moles will become, acetic acid concentration will get raised because of the addition of HCl. So 5 plus 0.1, HCl will get completely dissociated. So 0.1, so 5.1 millimole. And talking about sodium acetate, extra it got dissociated, right? Now I don't have sodium acetate as such. So 5 minus 0.1, that is 4.9 millimole. Correct? These are the millimoles we have now. So the total volume is 100. Now let's find out the new pH. That is equal to 4.74 plus log of 4.9 by 5.1, which is approximately, that's 0.9, correct, 0.9. So the new pH will be equal to 4.74 minus, after taking log value of 0.96, that is 0.0174, that becomes 4.72. They are asking the change in pH. So initially I had 4.74. Now I have 4.72. So the change, 0.02. That is your change in pH. Depending on the option, you can approximate and give the nearest value. The next question, this compound with red phosphorus Br2. If anyone know what is this named reaction is, let me know in the comments. Simple name reaction which affects the alpha hydrogen, which replaces the alpha hydrogen. So answer to this question becomes very simple, COOH and Br2 takes place over there. And both acetaldehyde and acetone individually undergo which of the following reactions? Acetaldehyde and acetone. Iodoform reaction, yes, it does have CH3 group attached with the functional group. Yes. Cannizzaro reaction doesn't want alpha hydrogens, correct? But here I have a lot more alpha hydrogens, so which will not. Then aldol condensation, it needs alpha hydrogen. I have alpha hydrogen, so it can. Tolerance test, it will do for aldehydes, only aldehyde or ketone, that difference we know. So, which will not. And Clemens reduction, both. C double bond O will become CH2, right? So, A, C and E are your answers. The quantum numbers of 4 electrons are given below. N is equal to 4, L is equal to 2, ML values are given. What they are asking is correct decreasing order of energy of these electrons. Okay, let's find out the notations, the shell's level. N is equal to 4, so 4. L is equal to 2. L value you know, right? S is 0, P 1, D 2, F 3. These values are azimuthal quantum number. So, which is 2, L is equal to 2, that is 4D. Okay, so let's check with another one. If we have any tie, then we'll go to magnetic and spin quantum numbers. L is equal to 2 again, then 4, L is equal to 1, P, then 3, P. Okay, so among this, which will have highest energy? 4T, 3D, 4P, 3P. Of course, D orbital will have highest energy, right? 4T. Then comes, I'll have 4P. Then 3D. After that, I'll have 3P. Okay. So the decreasing order is mentioned over here. Aromatic compound reacts with a molecular formula C9H10O, reacts with Lucas reagent and gives no reaction at room temperature. Okay, it can be benzylic or allylic substances are possible, which does not immediately react with Lucas. Let's move on to the next clue. Chromic acid. With chromic acid, it gives compound Y. Chromic acid, actually, if I'm having an alcohol with chromic acid, that primary alcohol immediately give carboxylic acid, and secondary alcohol will give ketone, right? It will not go up to carboxylic acid for secondary. What they are saying, it gives compound Y that is having only one oxygen, so it is not primary. It must be secondary compound, Xs. Then Y with iodoform test, it shows positive. So there is an CH3 group attached with the ketone. Y with Br2 gives monosubstituted product predominantly. Okay, so that must be in benzene ring, because I have C9H10O. You can find DOU also. And I have CH3 and OH, so that this part can get converted to CO group, that will give you positive to iodoform test. And I have C9H10O, which is not sorted out, so methyl substituted compound that can be possible. Another methyl group attached with there, because I can't take any tertiary compound which will not undergo oxidation also. So let's check how many. This is X, and this will give you compound Y, that is CH3, C double bond O, CH3, that can give iodoform test. And Y gives monosubstituted product predominantly. So where it occupied, so it can give only one substituted product. So how many number of sp2 hybridized carbon atoms present over there? So let's count the sp3 hybridized atom and let me know your answer in the comments. It's very simple. Practice more problems. Practice will give you more clarity. Please do practice. The exams are very near. Most of you are done with your exam. If you are done with your exam, let me know how it went. Identify the correct order of the given property for following compounds. Boiling point, density is given. Okay. So boiling point is depend on the 2-3 things, which is directly proportional to molecular weight and inversely proportional to branching. This rules remember than others. Okay. Then let's see one by one. First one is having Cl 1, 2, 3 carbon, 2 carbons, 3 carbons, 1, 2, 3, 4 carbons. Okay. This is right. What about density? Density is also more or less same as boiling point. So here I have bromo, chloro and iodo. Density increases with atomic mass increases. So bromo shouldn't be here. It should be in the chloro position. So which makes it wrong. And then boiling point again. Branching. So branching is inversely proportional to boiling point. As the branching increases, boiling point decreases, but here, as you can see, I'm having bromo groups more, so which will increase the molecular weight, so which makes this as a right. And density, again I have iodo and bromo, bromo and chloro and bromo. This is not right because chloro, bromo is there, and here I have only bromo, bromo and iodo. Its order shouldn't be like this. It should be density is directly proportional to atomic mass of halogen present over there. So clearly this is not a correct order. And what about E? I'm having same molecular formula, but branching is the thing. So which makes inversely proportional to boiling point, right? So which makes it right. So A, C and E all are right. An organic compound A, C4H11N shows an optical activity and gives N2 gas on treatment with nitrous acid. A compound A reacts with PHSO2Cl, producing a compound which is soluble in KOH. The structure of A is. So the options given are amine and then N with 2 methyl groups and 1 ethyl group, and this, and option D is primary amine. So they have mentioned C4H11N. It releases N2 gas on treatment with nitrous acid. So which must be N? Primary amine, because diazonium reaction you remember. So which is treated with, let's say I have primary amine, it will produce N2Cl, which is unstable. So it will produce ROH with N2 gas. The compound A reacts with PHSO2Cl2, that is Hinsberg reagent, right? So producing a compound which is soluble in KOH. So after reacting with Hinsberg reagent, it forms a compound which is soluble in KOH. So hence the amine is primary amine. In the following halogenated organic compounds, the one with maximum number of chlorine atoms in its structure. Okay, so here you can see chloride, gamma, zine, chloropicrin and ferroin 12. You must know the structure of these, then only you can answer to this question. Let's quickly see this. Chloral, which is Cl3C CHO, chloryl aldehyde group. And gamazine, that is cyclohexane with 1,1 Cl each. Then chloropicrin We know picric acid, which is aromatic, but here I have nitro with 3 chlorines in it, and ferroin 12, that is CF2Cl2. So obviously gamazine becomes your answer. In the next question, given below are two statements. Sulfonilic acid gives esterification test for carboxyl group, gives red color in Lysines test for extra element detection. So in the light of these statements, we have to tell. So sulfonilic acid, basically this will look like yes, double bond O, OH, on the other side NH2. Right. So it will not show any esterification test for carboxyl group, doesn't have any carboxylic group, and then gives red color with Lysines test for extra element detection. So presence of both sulfur and nitrogen is there to give Lysines test. So option statement 2, that is correct. Statement 1 is incorrect.